Here we have a shaft that is mounted to a wall, and there's external load of 30 Newton meters at the end, pure torque, and the diameter of first section is 15 millimeters, and we are asked to determine the diameter for section 2, D2, so that the total twist at the end of the bar will be 4 degrees. The shear modulus of the material is 80 gigapascals. So let's start by doing the free body diagram on this case. So we will do it like so. In here we have external torque. So in this case it's pretty simple, since we have torque on one end and the other end is fixed to wall. We know that there must be 30 Newton meters of torque also on the other end, like so. Then the diameter of this section is D equals to 15. D1 and D2 is question mark, and the length of the first section here is 200 millimeters, and the second section here is 250. Right. So we're gonna use again the formula for change of the angle, which is torque multiplied by length divided by second moment of inertia multiplied by shear modulus, like that. Well, now we have two different diameters of rods, which means that we have to calculate the change of the angle for both of those separately, since the second moment of inertia is different with different diameters. So the total change of the angle, we call it like that, is the change of the angle in section 1 plus the change of the angle on section 2. In this case, we have all the information that is needed to calculate the change of the angle for section 1, so we can calculate that one first. So that one equals to torque 30,000 Newton millimeters multiplied by the length, which is 200 millimeters for the section 1, divided by Ix, which is pi times diameter power to 4 millimeters power to 4 divided by 32 multiplied by the shear modulus, which wants 80 gigapascals, which is 80 10 times 10 to power 3 megapascals. Well, now when we solve this one, the value will be 0.01509, and the unit is radians. So now in this task we are told that the maximum twist at the end is 4 degrees. Well, let's convert the 4 degrees to radians. Well, 4 degrees equals to 0.06981 radians. And now the first section will twist with 0.01509 radians, which means that the amount of twist which we allow for the section 2 is 0.06981 minus 0.01509. So this one here is the maximum amount of twist that we want, and this one was the amount of twist that we are gonna get from the section 1. So what is left from there is the amount of twist that we actually want to get from the section 2. So 0.054 radians, like so. And now from the equation of twist we can solve what has to be the diameter of the rod to get that amount of twist. So we will write 0.05472 equals to torque 30,000 Newton millimeters multiplied by the length of the second section, which is 250 millimeters, divided by the section modulus of the second piece, which will be pi times d power to 4 millimeters power to 4 divided by 32 times shear modulus, which is 80 times 10 to power 3 megapascals. And from this one you just have to solve out the d. You have to solve what is the d. So when we do that, we get the value for d equals to, or d2 actually. So the value for d2 has to be 11.49 millimeters. So that's how you can calculate tasks like this.